Artificial intelligence. In a first, Google has released data on how much energy an AI prompt uses. It's the most transparent estimate yet from one of the big AI companies, and the long-awaited peek behind the curtain for researchers. By Casey Crownhart Archive page. August 21, 2025. Google has just released a technical report detailing how much energy its Gemini apps use for each query. In total, the median prompt, one that falls in the middle of the range of energy demand, consumes 0.24 watt-hours of electricity, the equivalent of running a standard microwave for about 1 second. The company also provided average estimates for the water consumption and carbon emissions associated with a text prompt to Gemini. It's the most transparent estimate yet from a big tech company with a popular AI product, and the report includes detailed information about how the company calculated its final estimate. As AI has become more widely adopted, there's been a growing effort to understand its energy use. But public efforts attempting to directly measure the energy used by AI have been hampered by lack of full access to the operations of a major tech company. Earlier this year, MIT Technology Review published a comprehensive series on AI and energy, at which time none of the major AI companies would reveal their per-prompt energy usage. Google's new publication, at last, allows for a peek behind the curtain that researchers and analysts have long hoped for. The study focuses on a broad look at energy demand, including not only the power used by the AI chips that run models, but also by all the other infrastructure needed to support that hardware. We wanted to be quite comprehensive in all the things we included, said Jeff Dean, Google's chief scientist, in an exclusive interview with MIT Technology Review about the new report. That's significant, because in this measurement, the AI chips, in this case, Google's custom chips, the company's proprietary equivalent of chips, account for just 58% of the total electricity demand of 0.24 watt-hours. Another large portion of the energy is used by equipment needed to support AI-specific hardware. The host machine's CPU and memory account for another 25% of the total energy used. There's also backup equipment needed in case something fails. These idle machines account for 10% of the total. The final 8% is from overhead associated with running a data center, including cooling and power conversion. This sort of report shows the value of industry input into energy and AI research, says Moshe Rothschild-Curie, a professor at the University of Michigan and one of the heads of the ML Energy Leaderboard, which tracks energy consumption of AI models. Estimates like Google's are generally something that only companies can produce, because they run at a larger scale than researchers are able to and have access to behind-the-scenes information. I think this will be a keystone piece in the AI energy field, says Jay Wanchon, a PhD candidate at the University of Michigan and another leader of the ML Energy effort. It's the most comprehensive analysis so far. Google's figure, however, is not representative of all queries submitted to Gemini. The company handles a huge variety of requests, and this estimate is calculated from a median energy demand, one that falls in the middle of the range of possible queries. So some Gemini prompts use much more energy than this. Dean gives the example of feeding dozens of books into Gemini and asking it to produce a detailed synopsis of their content. That's the kind of thing that will probably take more energy than the median prompt, Dean says. Using a reasoning model could also have a higher associated energy demand, because these models take more steps before producing an answer. This report was also strictly limited to text prompts, so it doesn't represent what's needed to generate an image or a video. Other analyses, including one of MIT Technology Review's Power Hungry series earlier this year, show that these tasks can require much more energy. The report also finds that the total energy used to fill a Gemini query has fallen dramatically over time. The median Gemini prompt used 33 times more energy in May 2024 than it did in May 2025, according to Google. The company points to advancements in its models and other software optimizations for the improvements. Google also estimates the greenhouse gas emissions associated with the median prompt, which they put at 0.03 grams of carbon dioxide. To get to this number, the company multiplied the total energy used to respond to a prompt by the average emissions per unit of electricity. Rather than using an emissions estimate based on the U.S. grid average, or the average of the grids where Google operates, the company instead uses a market-based estimate, which takes into account electricity purchases that the company makes from clean energy projects. The company has signed agreements to buy over 22 gigawatts of power from sources including solar, wind, geothermal, and advanced nuclear projects since 2010. Because of those purchases, Google's emissions per unit of electricity on paper are roughly one-third of those on the average grid where it operates. AI data centers also consume water for cooling, and Google estimates that each prompt consumes 0.26 milliliters of water, or about 5 drops. The goal of this work was to provide users a window into the energy use of their interactions with AI, Dean says. People are using AI tools for all kinds of things, and they shouldn't have major concerns about the energy usage or the water usage of Gemini models, because in our actual measurements, what we were able to show was that it's actually equivalent to things you do without even thinking about it on a daily basis, he says, like watching a few seconds of TV or consuming 5 drops of water. The publication greatly expands what's known about AI's resource usage. It follows recent increase in pressure on companies to release more information about the energy toll of the technology. I'm really happy that they put this out, says Sash Luxoni, an AI and climate researcher at Hugging Face. People want to know what the cost is. This estimate and the supporting report contain more public information than has been available before, and it's helpful to get more information about AI use in real life, at scale, by a major company, Luxoni adds. However, there are still details that the company isn't sharing in this report. One major question mark is the total number of queries that Gemini gets each day, which would allow estimates of the AI tool's total energy demand. And ultimately, it's still the company deciding what details to share, and when and how. We have been trying to push for a standardized AI energy score, Luxoni says, a standard for AI similar to the Energy Star rating for appliances. This is not a replacement or proxy for standardized comparisons.